Gentle if I do some mistake. So I speak about a bit about me, a brief introduction. I started working in IT formally in 2021 as a freelancer. First, I spent 10 of the youngest year working in Italian public administration, where I wasn't an IT guy. And what I've seen from my first project is that everybody can start easily to write some Python code. But what I'm doing right now today is showing how to use Docker, because Docker can be the first step in your career towards DevOps, towards data engineer, or towards other profession. That's why. That's because everybody here could be a data scientist. If you are a data scientist, raise your hand. If you are very, very discreetly, I see very few hands. If you are a back-end engineer or developer, raise your hand. Okay, lots of back-end. If you are a machine learning specialist, engineer, and so on, or other professions, no hands. 1, 2, 3, 4. Okay, and all the others, are you front-ender? Or, I don't know, or just students that have to find their way? Well, to be brief, I started working as a digital nomad in the last 3 months, following the PyCon path from Taiwan in the end of September, then to Indonesia. And finally, I'm here in Hong Kong. I'm very glad to be in Hong Kong with you. And my future plan involves opening a no-profit school in Indonesia. So if you're interested to come as teacher for a 1-3 months vacation, I'll gladly accept, and please leave my contact me. Then we enter in why Docker. This is the core concept. We enter with this meme, which is quite famous, and means everybody can make the code works, and before Jupyter Notebook, it was also an issue, make your code work on your computer. And while right now, we can use Docker to pack our environment and distribute to the other computer. What is Docker? Docker is composed by an ecosystem of application. We have the client, which is just the command line working on our computer. So we have Docker build, Docker pull, and Docker run as main commands. But we don't have to use the client on a command line. We can use a graphical user interface to use it. The strategy is building some images. Those images are the complete computers together with our program. And to do this, we are using some images that are composed by an operating system plus your code and your libraries that you will deploy in a container. I'm getting very fast. I don't know how many of you already use Docker or okay, and who is hearing what is Docker for the first time? So I will decide how to go. Okay. I see. If you want to deploy, why Docker and how to use it in the deploy. We have that Docker allows us to put our code together with our Python environment directly in a so-called container, which will include everything you need to execute the application. So instead of having to install Python on every machine, you can just have Docker installed, and it will prevent all the problems about requirements, issues about Python version that could be different from one application to another. This is partially solved with local environments, but the idea of Docker is to serve some images like it was in the past. You insert a CD-ROM, and it will execute by itself. And how can it be useful for the deploy? For the deploy, you see that Docker can also be included in Kubernetes. There were some talk about Kubernetes today. I don't know if you have attended it. That allow you to create a swarm of virtual server. And you can use Docker as an image that will be duplicated and propagated to execute your code. I think it's very complex like this. In a simple way, we can see that to execute a program, we need our source code plus the Python libraries, plus the system libraries, and an operating system. We use this Docker layer in between to have multiple operating systems on our computer, so that we can run on the same laptop, for example, our web application together with a test database, together with other services. So when there is more than one application, we can use this system to test everything on our laptop. We start with something very simple. Let's imagine that we start with have to build. We have finished to code our web application, and we have to send it to somebody. We create a Docker file, and on the first line of the Docker file, we have to choose a starting point. We choose these images like when we go to the supermarket, you go to the shelf and you pick the product you want. You can pick all the ingredients. Maybe you want to do some noodles. You can choose between picking instant noodles, which are already prepared, or you can pick the flour and do your noodles by your hand. So the good answer is that for Python, you have already 3 flavors of instant noodles ready. You have a Python, normal Python, which is the one on the your left, standard image, which is based on a Debian solution, and it's very compatible, but it's also very heavy about size. We have a Python Slim, which is a compromise that has this Linux operating system, always Debian based. They should be bookworm right now. And the alternative is also Alpine, which is a very optimized system based on this having a very few application inside, but also means that it could be very problematic because sometimes you have to fight to have every tool you need. So the suggestion, but everybody will choose Python Slim as the initial tag. I talk about something that you will not find easily around, so the necessity to add a security layer. This is because Docker images are executed on top of your system, and if your system is not protected, you could have some attack. So the idea is to run everything by using a custom user in a custom group. This is because it's Linux. I don't know how many of you have ever used the Linux. If it's a few, it's good because most of the problems come because we use Docker on Windows and then we have to deploy on Linux, and so a lot of unexpected things may happen. So here I'm showing a few lines. This is like infrastructure as a code. We are creating an image by writing some codes. In the first line, we create a group and then a user of this group. And in the second block, we are copying the requirements from our hard disk to the new image and install those requirements. I also here write to use args and environment variables whenever possible. This maybe is for the future when you will write the first application. If you have questions, I think we will do it at last. Okay, we have 15 minutes. I will show some horror stories of my career as a freelancer. I had to anonymize a bit because, but they are not all mine. I think some come also from other sources to save me from legal reason. So these are the stories we are going to see today. For the last point, I know that MySQL is a silver sponsor here. So I hope they will not do anything bad. But I have to share these stories. So first story, also to teach what is Docker image, is that the Docker images are made like layers of a cake, and every command like run, like copy, or add, but we will not see it today, will create a new layer of the cake. So it's very important to optimize and reduce the number of run. For the ones that have never used Linux, apt-get allow you to use the packet manager inside Debian or Ubuntu, which allow you to install remote programs, remote packages on your computer. Also, we are using wget, which allow you to download some files from the web, and eventually, if these files are packages, we can also install those remote packages. This is not optimized also because we can install multiple packages on the same line, and also because we are creating, for each run, we create a layer, different layer of the cake. What is a layer? A layer contains all it's like a small image, and we are building every image as a by stacking this kind of layers. The solution is quite simple. We create a single layer by using this ampersand, this commercial hand, and combining all the lines into a single command. And also, we don't forget to remove what we don't need for our Docker file, because every file will affect will stay there until you delete. If there are some questions, we can do it now or on the end, but I will go fast because we don't have much time. Sometimes we are tempted, or we will not follow the order of layers. In the first line, you can see that we are starting from the Instant Noodles Python 3.12, which should be now quite stable, and in the slim flavor, so that we are not using we don't need the full image, and this allows us to have an image that weight I think like 1 gigabytes instead of 2, 3, and it may affect your hard disk and also your time in which you are building the image. Here in the second line, we select to the directory in which we are working. Then we copy all our local app code inside this directory of the image, sorry. And finally, we install the requirements. And this is a wrong order of layers. Why? Because your code will change a lot until the end of the application. So while the requirements, more or less, we are using always the same libraries, or we will add some requirements on a new feature. But if you're going to do a bug fix, we are not going to change the requirements. So sorry for the caps lock here. We have to follow this kind of rule. So we start with user creation for security purposes and system update. We install the external libraries by apt-get. or apt or other package manager. We install the requirements, and finally we copy our code. So that if we copy our code, we remove the top layers from our cake and we just copy the new code, and we don't have to reinstall everything. It happened on some project that I had to install external libraries, like 5 gigabytes of external libraries, but the original writer of the Docker file put them at the last point because they were external, so who cared? Problem is that every time you had to recompile the image, you had to re-download and install 5 gigabytes of libraries. Very fast. You don't want to have your Docker file inside your folder application, because sometimes in a bigger project you can have external model, common model, like if you have to deal with the logs or utility. And I think that this is something I discovered by practice, that Docker for security purposes don't allow you to include in your image all the files that are in the parent directory. This is because sometimes I can do a malicious Docker, include the files, or maybe 10 directories up. I go to your C folder and take everything and send it to a malicious server that will steal your file. Docker is safe for this, so will prevent you from including those kind of files. And so a better project structure for, I see as a note, use a better naming, because I use EP1, EP2, EP3. I'm anonymizing one of my projects. So we should put all the common libraries outside the application folder, and also all the Docker file outside of the application folder, so that we can include. And now I will talk about the problem of using Docker on Windows or on Linux. The main problem is that when we save file, there is a huge difference. Here there is a service of Docker Compose. In Docker Compose we can define some volume so that we will map the image files over our file system, and we can retrieve the files that the app will create. The problem on this is that those files are saved as root user if you don't put a user, or in our custom user, and those files are not usable for the final user because maybe it doesn't have the permits, or maybe we have to share, but there could be some issues. And this we will notice only on Linux, because on Windows, Docker is executed by WSL2, and so we don't have a real user system in Windows. We have a fake user system, and this problem will not be shown. We have another problem, here is SQLite. SQLite is another horror story, because it doesn't deal with concurrency. I'm getting too fast, I saw some photos. So if you have multiple services, maybe a web application, then some process that will parse and connect to SQLite. Given that this database is a file and not a real DBMS, you will not be able to modify and to see this modification in real time. So it happened that you have a dashboard connected with SQLite, and it will not show any progress. So it's very, very bad. So we change. The recommendation is using Postgres. I'm not paid by Postgres, but I feel that it's the safer choice, even because here we are going to the problem. MySQL nightmare. And we have 5 minutes left. What was my MySQL nightmare? The problem is that online you cannot trust any sources about Docker file or Docker Compose. Even ChatGPT is wrong. there are Docker Compose older version of Docker Compose file, which has the version tag, and but it's not needed anymore in the new version. And the problem with MySQL is that in version 5 they didn't have a SSL policy, and also different user management. So if you are downloading some from GitHub, a Docker file made it for MySQL, but some years ago, nothing will work out of the box. So also, this is not enough as a problem. Sometimes you're building Docker with also other project. Maybe a C file, a C project, or a Rust project, or other compiled project, and they need on Linux the driver, MySQL connector, and so on. Problem is that since MySQL get owned by Oracle, they update it a lot, which is good, but they remove the old ones. So your Docker file with Vuget will point to the old version and will tragically fail. And this is one of the problems. So the solution is for me, if you want to sleep a good night, maybe for Docker, avoid MySQL. But if you have a good team, maybe you can manage all the version of the connectors, all the dependencies. But you always have to monitor the dependencies if they are external, because the instant noodle, the Python, your Python flavor of the image is well maintained by others, but all the external dependencies will not be managed by others. So if you have no time, if you are a one-man army, you work alone, maybe there are other practical situations. And I think, yeah, I have other nightmare that I didn't have the slide. So until it's time, I will talk about another nightmare. It's about cron. How many of you know what is cron? 1, 2, 3, 4, 5, 7, 10. Okay. You can schedule to execute, for example, a program every day at midnight by using a cron, which will execute the program for you. The problem is that inside the Docker, cron doesn't work. There exists at least 20 guides online that will explain how to use cron with Docker. They don't work. So keep your hopes in peace. Don't use cron inside Docker. But if you have a Linux server, install Docker there, and then in the Docker in the cron of the Linux server, put the Docker run program command, so that you can deal directly. 1 minute left. You will deal directly with, you will let the server do the real schedulation, and you can call this Docker or Docker Compose. Unfortunately, I could not speak about Docker Compose. It's one of my favorite topics, but next time, I think. Thank you for your time, and if you have some question, I'm here for the next 5 minutes. You can connect on this QR code with me. There is one question up there.
Yeah, thanks for the talk. Have you thought about instead of using Docker Desktop, using microcates from Canonical or Minishift from Red Hat as your Docker layer on your desktop? Because that way you can solve a lot of the problems that you're having, and also be more ready to make your code production ready because it's already in a Kubernetes environment.
I think that's true. One of the constraints I always said is working on a Windows machine. So on a Windows machine, I think a canonical tool doesn't work, but maybe...
Minishift is really good.
Okay. I will try. Are there other questions? Even there is no stupid question, so feel free. Okay. I feel no. I don't see any hands. So yes, one hand.
I've tried to use Docker inside of, I think, VM sphere. And the problem I encountered is with the IPs. And I think Docker made up this, I think, IP internally or something like this. Somehow it crashes with the VM sphere IP.
Yeah, one of the team of Docker is also the IP problem that we create an image that inside the container will have a different IP, and also it needs to connect to the external, maybe to the local host with outside of Docker. So there are some strategies to deal some internal keyword you can use for having this. Or also another choice that I did in one of my projects is to create a parameterized Docker file, and by bash script I will put the right IP or services. But this is not needed if you're using Kubernetes, because there you can select the IP, the address of the service by targeting the service. But with VMsphere, I don't have a solution out of the box right now. So maybe we can talk later, I think. Or, okay. You're the boss.
All right. Thank you, Cristiano. Let's put our hands together for him.